Okay, so we're going to use the half-angle formula. And the half-angle formula goes like this. Cosine of x over 2 is equal to the square root, and I'm going to keep track whether it's positive or negative, of 1. Cosine likes itself, so plus cosine of just x, not x over 2, and then the whole thing over 2, okay? And that 2 is on the inside of the radical. Maybe that's hard to see, but it's in there. And, okay, so I'm going to use that. And I'll write out your tangent one next to it when I'm done so you can see what to use. So let's see. I have, well, let me just write that down. I mean, do I need to do anything else? I'm going to say 1. Instead of cosine x over 2, I'm just going to say 1 plus the same thing, cosine x over 2. And I'm going to move the sine x to the other side. So I can say equals sine x, because I would like to square both sides. Now, when I say square both sides, your spider senses should be tingling, because it's possible that I introduce an extraneous solution or two, but we'll think about that later when we check our work. Okay, so there we go. I squared it. Now here's the thing. I don't want sine and cosine, so I fall back on my good old favorite. You know what I'm talking about. Sine squared x plus cosine squared x. I shouldn't even have to mention this, right? We just know this. So I have 1 plus cosine x over 2 is equal to 1 minus cosine squared x, because I don't want sine, I want cosine, and if I solve for sine up above there in the Pythagorean identity, then I get this. Okay, so let's multiply everything by 2. I think I'll come up here and finish up here. I have 1 plus cosine x is equal to 2 minus 2 cosine squared x. And I suppose I'll move things to the other side, and I will end up with 2 cosine squared x plus cosine x minus 1 equals 0. Okay, so everything's collected on one side, and the question is, can I solve this? And let me just say that, you know, I'm basing it on the algebra that looks like this. And I think to myself, can I say 2x? I guess I'd say minus 1, and then I'd say x plus 1. Is that what I'm going to get? Does that work for me? X squared, 2x squared, 2x, take away 1x, and I get, yeah, that works for me. Okay, so I go back to what I really have here. I really have 2, instead of, you know, when I did this, I substituted, and x is equal to cosine. So that was my substitution. And let me put it back now. 2 cosine x minus 1, and cosine x plus 1. All right, and I'm going to solve both of these for 0. Not as bad as the last time, I think you'd have to admit. Not as bad. Last time was a doozy. So the cosine of x, when is that equal to 1/2? Because that's what I want. And the cosine of x, when is that equal to -1? Because that's what I want for 0. Well, I can answer this pretty simply. X is equal to... that's going to be 60, right? Do I need to draw the reference triangle? You draw the reference triangle, and you see that x is equal to pi over 3. And also, if I want it to be a positive half, and I do, 5 pi over 3. And also, x is going to equal, if I want it to be -1, it's going to be pi. Okay? So those are my answers, and when I graph it and put the graph into the notes, I certainly hope to see that this formula, this original formula up here, does cross at these points right here. Okay? And as promised, I will go ahead and write the tangent what do we call it? The half angle formula. Seems kind of backwards, but anyway, that's fine. And that's good.